I have a certain aesthetic want from the part.
So the interesting thing I find here is that you're using a rough sketch that's sort of a generalized idea, and then what you're doing is using a caliper. Is a caliper
right.
to basically then turn that into actual measurements, which you're then just simply plugging into your software to build to construct a digital model.
That's right.
Okay, well that's kind of interesting, actually.
Yeah,
So do you have folks who actually would instead take the drawing and actually put down on like a digitizing tablet and digitize it that way, and then basically attach measurements to that line drawing, or is this a way that it's normally done?
This is a technique that I've developed, but what it is I think where it's a fair representation of what other engineers do, is that it's commonplace, I think, for engineers to start from a sketch that somebody comes up with, and somebody is going to say to them, we want this thing to look a certain way. And, designers, for example, are going to, throw them something that's in a less formal format, like a sketch, and then the sketch will have to be brought into CAD. So what we're looking at here is I'm doing the job of designer and engineer, I think, essentially.
Right. Which is, sort of how it used to be in the good old days, or bad old days.
Yeah. Well, the goal is, though, that I want to be able to create parts that are both, aesthetically valued and also viable engineering parts. I want these flanges in the bottom to come closer together. That's more in keeping with what the sketch is telling me.
But you go ahead and grab the object and you can rotate it a little bit.
Sure.
Okay, that's good. All right.
So now what I can do with this software is I can go back to the sketch mode, edit sketch. It's back into a 3D sketch. Come in closer to it, and now I'm going to adjust these distances in the bottom. Instead of 4.5 for that base distance here and here, I'm going to make that into something more like 2 millimeters. And you can see that my proportions are not too far off here. Once I gave that 16, you see how it butts up there against the edge?
Yes.
So what I'm doing here is, it's kind of this is not an exactly scientific behavior here, but
it's a combination of engineering and aesthetics.
Yeah. Now you notice here I want that edge to mate up with this, and I don't want there to be any crack in there. So what I'm going to do is I'm going to say coincident. And what coincident does is it makes sure that that point mates up with that curve. I've also made sure that the center point of the circle mates up with the centroid of the sweep rotation. Now watch as I go in here with the trim tool and I start to remove some of the other artifacts. I come in and I take out that part of the circle that we won't need in the sweep, this part here that we won't need because that's enveloped in the part right there.
That's really amazing.
Oh, this is not one of my better parts. But so there we have the pawn, right? View from the front. See how they're lined up with each other now?
Absolutely.
Okay. Now here comes the time when I can export this into a format called STL. STL stands for stereolithographic format. And what it will do is it will take these 3D entities that I have here, and it will turn them into a collection of planes. Each of those planes will have will be triangular shaped, and in order for the planes to have any geometric meaning, there will be 3 points for every plane and one additional piece of data which represents what's called the unit normal. You see how that bulges out there on the sides?
Yeah.
I might like to remove that. And I have an idea for how to do that. It won't take very long. You mind if I do that?
Go right ahead.
Alright, I'm just thinking it could be prettier still. I've seen this error before. I've been able to work around it. Of course, I fixed it in ungodly hours, man.
Yeah, sure.
Set units, convert units.
Let's go for scale for now.
Well, I'm thinking, you say,
Even smaller.
son of a mother. There's no undo, of course.
Go to edit. If there's an undo, it's going to... He's even recording it. You better get it to work.
Yeah,
This is another critical life skill.
unload box. Yeah, there it is, mocking the build platform. You want to build this file, don't you? Pussy. Open. Yeah, I'll convert it now. Did I convert it last time? I can't remember.
You did. It's even smaller now. It stored your last setting and it's doing it again.
It's mocking it. Alright.
Don't trust the software. Do a manual scaling. It will work.
Well, a manual scaling will not give me nominal size. Man, I really don't want to use this setting because it doesn't look like it has any support material on it.
No, it doesn't.
And quick cast, that's just going to suck.
That's not going to affect it. Still doing the same thing.
Hey, Homer.
Yes, sir. Yeah. Okay, you want to carry one home?
Homer, do you have any experience with the Lightwave software
He's the man, right?
or Lightyear?
Yeah, but I don't remember.
No one. Well, the problem is that the errors
The
errors change over time.
It's got something to do with whether...
Jason fucking with it. That's what it has to do with. I'm gonna have to strap him.
What is your default setting in SolidWorks? Is it an mm unit or inch?
If you have features that are cantilevered, or let's say, for example, if you had the letter T, and the letter T is being built from its base up, those edges that extend from it would droop down unless they were supported, because in stereolithographic and other rapid prototyping technologies, things are built from the bottom up.
Right.
So, if we look in closely here at what I've done, alright, see how there's scaffolding in there?
Yes.
I'm going to get even closer. That will physically be on the part in order to keep it from drooping. And you see, as I rotate it around here, see how some of those curves, those flanges that were sticking out before,
Right.
they have to be supported. If they're not supported, when they're built in the resin, they'll droop down. It'll be dreadful. So what this does is this allows it to have intermediate structure that supports it throughout the duration of the build. And that will all be broken off when we go to the curing or the treatment process later on. Now, if you look here, these things are not built directly onto the platform. They're on scaffolding as well. See?
Right.
So that allows it makes it easier for us to break it off the platform. Now, if you look at the part of the rook over there, the rook is not requiring any ancillary build because there's never a point. Remember, it's a twisted square.
Yeah.
So it's always being supported in here by the subordinate layer beneath. But in this, we have these cantilevered extensions. But everything here continuous structure that doesn't require any support. Now the next step is I have to create the slicing files, the cross-sectional builds.
This is the SOA machine. This is the machine that is basically you load your model, your sliced model into, and basically what it does is this is a vat that contains what resin or something?
It's a resin. This is what the parts look like when they're finished.
I see.
And this is a part it's had all of its support material removed, and you can see it looks like a plastic part.
Yeah.
It's got a nice smooth surface on it.
So what it's doing now is it's slowly dropping down into the resin, and then the laser is basically then selectively hardening part of the resin.
Everywhere the laser moves, resin is cured. And the laser is a UV laser. You see it has kind of a violet purple color.
Absolutely, yeah, I can see it right now.
Yeah. And you see how quickly it moves in there. The bulk of the time that this machine is building is spent waiting for the resin to settle. On newer machines, they have a wiper blade that comes across and smooths out the level. The newer machines also move in much smaller increments in Z. And of course, the laser moves with more precision, improving the build resolution. Ready?
Okay.
Do the same thing with this guy. You can see the skeletal structure on the back?
Absolutely. I'm shooting video right now, by the way.
Okay. And now look here at the support structure on the side. Even though it looks a little gooey, it's actually ordered what you would call trusses. It's a space frame of sorts. But when I remove this support material from here, it's going to be a lot more bare bones. There's very little support material on this guy because its geometry didn't require it. But on the pawn, on the other hand, we got a boatload of support material that we need to deal with. Here, it's almost like peeling shrimp, you know.
This is just extraneous lattice work that pops off.
Yep, support material is what we call it.
So it's not really the same thing as flash, extruded flash from like a...
Flash is a defect in molding. This is deliberately put there as part of the process. And as you see me pulling off this material here, you can see more and more just how nice our part is underneath. Because when you initially look at all that support material on there, you might think to yourself, man, that's not what I designed. You can see it's starting to emerge.
This is RTV mold material, and you're going to basically do a 10-to-1 ratio.
And it's by mass. So what I do is I first tear the mass of the container. This is mold mass 30. I have to shake this part up here, which activates it. It's the curative agent.
Okay.
So it says 100 to 10, but it's 10 to 1. And then what I'm going to do is this stuff, when you see it pour, it'll remind you of the old movies in school about how latex is harvested. It'll look just like latex. Okay, so 1852 is where we stop. it doesn't have to be exact, but it doesn't hurt if you get it close.
It's sort of like mixing epoxy. You don't have to get it exactly right, but you need to be fairly close.
Well, with this, you have to be closer than epoxy. All right, went a little over, that's okay. I take one of these spatulas here, I'll mix it up. It's important not to let marbling occur inside of this.
You want an homogeneous mixture.
Right.
Is getting air bubbles in the mixture a problem?
It is, and we're going to deal with that with this vacuum pump that's right next to you.
Okay.
See that? That's a two-stage vacuum right there.
This guy right here?
Yeah, we're going to put this mix in there before we pour it, just to remove some of those bubbles. Right now, the important thing is to make sure a good, even, thorough mixture happens. When we put it in the vacuum pump, you'll see the material almost froths up on the inside. One of the nice things about these semi-translucent containers is I can see some of the unevenness in the material. Okay, put that in there. This is a two-stage vacuum pump. It'll draw a very, very high vacuum. Check to see if the lead, see. Now at first you won't see much more than a little bubbling, but as the pressure in the inside decreases, the boiling point of the material might be reached, and we don't want the material to bubble. The boiling point is a function of temperature and pressure. Decreasing the temperature or decreasing the pressure of any liquid or slurry will effectively lower its boiling point. Well, what we're trying to do here is just degas it. So we don't want to boil it. If we boil it, then we can also partially cure it. And if it's cured, then it's not useful to us. We want it to cure around the part. I'm going to jar it a little bit. And you can see how it's bubbling up there. I'm going to release the vacuum. It comes down like a falling souffle. That's probably all right for our purposes.
Fantastic.
Now it's time to pour the material around, not onto the parts. We want it to envelop the parts, not to coat them. If it coats them instead of envelops, then we may miss some of the detail.
Yeah, you want it to fill air. You don't want to pour it on top because then you may end up with some pockets of air.
Yeah, and then that will diminish part fidelity. So just like cake batter, I have to kind of start scraping this stuff out.
Looks like you almost
I missed some of it.
Oh, at the very
A
bottom.
little marbling, yeah, but when you mix that much, it happens sometimes. It's not the biggest mold I've done. We'll probably need to mix up a little bit more, and it's okay because the pot life, or how long it takes for the stuff to cure, is long enough that I can add in a little bit more without there being any kind of a welding line or something in it. But for now, I'm going to degas that part of it again. because we accumulated air on the way in.
In the process of...
Yep. So degas that a little. There. Make sure we got a good seal. Our vacuum's seen better days. Not getting a very good seal, so let's come through, fix the seal. Then over here on the scale, I'm going to tear it out so that now when I pour more material in, my base is 0. And I'll be able to make a good mixture there.
You see it bubbling a little bit.
Yeah, it's good degassing. Bubbles will, if there's a bubble in there and it happens to be along the side of the part, then you'll get material where you should have had no material. So now I'm going to remove the vacuum very slowly. The mold I normally cut along with the glue lines so that I get a smoother cut.
I guess we should tell our audience this is several days. This is 44 hours later, and this is an RTV compound that we poured yesterday through our mold, and now the mold has hardened.
It's cured.
It's cured, excuse me, and we're now he's now liberating it from the mold.
So I like to just cut through all the hot glue first.
Right. There we are.
I used enough release agent that came off easily. Remember I put a ton of that on?
Yeah.
Well, that's one of the virtues to it. That, see, that was perfect release right there. Isn't that nice?
Absolutely.
Alien flesh. Let's go through here and loosen up this. So that hardboard that we're using, it's not cardboard, it's hardboard. We can sometimes reuse it depending on how careful we are removing it. But these are good to use again.
It's like fiberboard, the same stuff that's used to make pegboard, basically.
Yeah, it's a lot like that. So I'm just going to cut off some of the superfluous material here, which doesn't matter at all. It's
just aesthetically, yeah.
Okay. Now, see where these 3 supports are here? These
Yes.
3 pieces of metal.
Absolutely.
Those are the parts that's where the parts are being suspended. So I'm just going to cut through the mold like this, all right? Just parting it. This is literally called the parting line in the mold. And the parting line, we use that term in all sorts of molding processes. We talk about the parting line in RTV molding, like we're doing here, or the parting line in injection molding, or even in sand casting. All right. Now we have 2 mold cavities. 2 halves pull the part of the metal out here to help me see how easily that came out.
It pops right out.
Yeah, well, this is a silicone-based material that we're molding in, so it can be very forgiving. Now we need to have a way for the plastic to be poured in. So that is called a sprue. I'm going to make just openings here. See how I'm just kind of scoring this?
Yes.
Now I'm going to cut around like so. I have positioned my parts in such a way that the sprue marks, the sprue artifacts, will not be so visible to people looking at the part. I put them underneath the part.
I see.
And so that improves part aesthetics. It's important not to have debris in the part, in the cavity, because the debris will disrupt the shape of the part. So at the top of the sprue, I create kind of a pouring cup, is what we call it. Try and smooth it out a little bit so it creates less turbulence in the liquid that's being poured in. Turbulence can kick up some air. I'm going to sprue the other side too. Making a pouring cup now for the rook. This is called a urethane resin.
And this is mixed by volume.
Equal parts by volume.
Right.
And in fact, since I have terrible depth perception, I'm going to ask you to tell me if you think they're even.
That one, they're close.
Which one has more?
That one has more.
Does it?
You just need like a smidgen. Yeah, they're pretty close now.
Okay. Now, let me mix one into the other. First, let me see if this power's on. It is. Is the pump on?
Yes.
Good. Okay, so we're going to mix these two together. This has a fairly short pot life. That means in about 5 to 7 minutes, it will change phase entirely. And we'll demonstrate that. Mixing thoroughly. There will be an exothermic reaction, a noticeable output of heat. Now, just evenly and poorly, evenly pour into the cavity. See the bubbling coming out of there?
Oh yeah.
Yeah, that is why we're going to have to put on the vacuum. There's really no avoiding it. Even though we put in ventilation schemes and all that other junk. Now, it'll bubble out quite a bit. Now, one of the things about this resin stuff is that it cures faster aerobically than anaerobically. So in the presence of air, it cures much faster. In a vacuum, however, it cures more slowly. So what that'll tell you is that the outside will cure more quickly than the inside.
Right.
If you try and judge how solid it is on the inside by how cured the pouring cups are, then you could make a big mistake in opening the mold early, and then what you have is a goo.
Okay, it's all foamy.
It is. remove the other.
Several minutes have passed, and of course the acrylic has now hardened.
The urethane.
Urethane, I'm sorry.
Okay. Now pull at the parting line and see what's in there.
Oh my gosh.
Now, the parts may be softer than they look, so I'm going to touch them. This one I think is okay.
Wow.
That's the substitute part that we talked about.
Wow.
All right, that's safe to touch barehanded. Here comes the rook. Still a little soft. You can see me working it by hand. So we probably opened it a little early. It's still okay. You can see here a little artifacts from bubbling.
Right.
But for the most part, this represents the original. It's very close. Because that one's still a little soft. See how that vent is used? See that stream from the vent?
Yeah.
And so I can tell because I can work this in hand and it's not brittle, that I probably should have let it cure just a couple minutes more. But both of these parts are perfectly salvageable.
Absolutely.
So just flex the mold off from around it. There's the pawn. And all it needs is a little post-processing. Remove those support materials from the bottom. And we can repeat the process. Let's do it, too.
Okay.
Let's make another one.